Mars has captivated humanity for generations. What bizarre secrets is the red planet hiding just out of sight? Our robotic detectives, the rovers and orbiters, have uncovered a collection of 30 truly strange and mysterious findings. You are about to see the evidence that challenges everything we thought we knew. These discoveries range from a famous face carved into the landscape to seasonal gas spikes that hint at an active world. By the end, you will know the most perplexing Martian puzzle scientists are still trying to solve. Is the planet whispering clues about a hidden past? What do you believe is waiting to be found? A single photograph from the Viking orbiter in 1976 ignited a firestorm that would burn for decades. It appeared to show a colossal human face nearly 2 miles across, staring up from the Cydonia region of Mars. The public imagination went wild. Here was what seemed to be undeniable proof, a monument left by an intelligent, ancient civilization. Conspiracy theories flourished, suggesting NASA was covering up the truth about this alien artifact. The idea was intoxicating. It suggested we were not alone in the universe's history, that another society had once looked to the stars. But science demanded a closer look. Decades later, new orbiters with far more powerful cameras flew over that same spot. They captured the face in stunning detail, revealing the truth. It was not a carved monument, but a natural mesa, a large hill with slopes and shadows that, under just the right lighting conditions from a specific angle, tricked our eyes. This phenomenon even has a name, pareidolia. It is the innate human tendency to see familiar patterns like faces in random shapes. We see the man in the moon or a dragon in the clouds. The face on Mars was the cosmos's most famous example of this very human glitch, yet its cultural impact was immense. That one blurry image did more than just create a myth. It fundamentally shaped our collective curiosity, fueling a deep and lasting desire to ask the big question: if not a face, then what other secrets is Mars truly keeping? That very human desire to see patterns did not lead us astray, but simply down a different path of discovery. Our next strange find is one of pure geology, yet it tells a story just as compelling as any mythical face. Scattered across the Meridiani Planum, the Opportunity rover found a landscape littered with billions of tiny gray spheres. Scientists affectionately called them blueberries. These were not fruits, of course, but strange little stones, perfectly round and embedded in the rock or loose on the surface. They looked utterly alien, like a vast field of ball bearings left behind by some cosmic machine. The mystery of what they were and how they formed became a primary focus for the rover's mission. Analysis revealed these blueberries were made of hematite, a mineral that forms in the presence of liquid water. They are concretions created when mineral-rich water flows through porous rock. Dissolved particles of hematite slowly gather around a central nucleus, a tiny speck of dust or sand, and precipitate out of the water, building up layer upon layer over immense periods until a perfect sphere is formed. It is a process not unlike how an oyster makes a pearl. On Earth, we find these same spherical concretions in places that were once saturated with groundwater. Their presence on Mars was a quiet but monumental announcement. They were not a sign of life, but they were something just as profound, chemical proof of a once wet world. This was not a catastrophic flood, but something gentler and more persistent. A time when water trickled through the subsurface, saturating the ground and leaving its mineral signature behind. The humble blueberry became one of the most powerful pieces of evidence that Mars had a long and complex hydrological history. It demonstrated that the most revealing clues are not always grand sculptures or strange shapes, but can be found in the smallest, most ordinary-looking stones if you only know how to read their story. Sometimes the most baffling mysteries are not vast landscapes, but small objects that appear where they should not be. The Opportunity rover provided a perfect example of this when it sent back a pair of photographs taken 12 days apart. The first image showed an empty patch of Martian soil. The second, captured from the exact same spot, revealed a rock that had simply materialized out of thin air. It was a bizarre sight, a stone roughly the size of a jelly donut with a dark red center and a bright, sugary white rim. Scientists at NASA were genuinely stumped. How could a rock just show up in front of their rover? The immediate and most exciting theory was that it was a meteorite, a fresh piece of another world that had landed right at their doorstep. But the rover's chemical analysis told a different story. The rock, named Pinnacle Island, was incredibly rich in sulfur and manganese, elements that are highly soluble in water. This composition was a huge clue. It pointed toward a past where this material had formed in a wet environment, perhaps even a small pond of standing acidic water. The mystery of its sudden appearance was solved not by looking at the rock itself, but at the rover's own tracks. The team realized that just a short distance away, Opportunity's wheels had accidentally nudged a larger rock. That small disturbance was enough to send Pinnacle Island tumbling across the soil, flipping it over and exposing a side that had been buried for potentially billions of years. This whole event was a wonderful piece of scientific detective work. It showed that the Martian surface is not a static museum display, but a dynamic place where even a robotic geologist can rearrange the exhibits. The real discovery was not the rock itself, but the story it told about a wetter, more chemically active Mars, a story that was only revealed because a rover's wheel gave it a gentle kick. While Opportunity was solving the mystery of a wandering rock, its larger cousin Curiosity was about to stumble upon a very different kind of geological celebrity. Driving through the sandy expanse of Gale Crater, the rover's cameras caught a glint of something extraordinary. There, lying amidst the familiar reddish-brown, dusty rocks, was an object that seemed completely out of place. It was large, dark, and incredibly shiny, reflecting the weak Martian sunlight with a metallic gleam. Scientists named this strange visitor Lebanon, and it was immediately clear this was not just another piece of the local landscape. Its smooth, almost sculpted surface and brilliant luster stood in stark contrast to everything around it, which was dull, eroded, and coated in fine rust-colored dust. Analysis confirmed what its appearance strongly suggested. Lebanon was not from Mars at all. It was a visitor from the depths of space, an iron-nickel meteorite that had crashed onto the planet's surface in the distant past. This was not a small pebble either. It was one of the largest meteorites ever discovered on the Red Planet, a substantial chunk of extraterrestrial metal that had survived its fiery descent. Finding such an object on Mars is a scientific bonanza for a very specific reason. Think of Mars as a giant natural museum. Its atmosphere is thin, its climate is dry and cold, and geological activity is minimal. This means that a meteorite that lands there can sit on the surface, virtually unchanged for millions or even billions of years. It is preserved in a way that a meteorite on Earth, where rain, oxygen, and biological activity would quickly rust and erode it, is not. So when a rover like Curiosity finds a meteorite, it is collecting a pristine sample of the early solar system that has been delivered and kept in perfect storage. The Lebanon meteorite is more than just a shiny oddity. It is a time capsule, a piece of the raw material that built the planets, and its presence on Mars gives us a clearer window into the composition of our cosmic neighborhood than we could often get from our own world. But the search for Martian clues is not always about what we can see. Some of the most profound mysteries are completely invisible to the eye. For years, our most sensitive scientific instruments have been sniffing the thin Martian air, and they have detected something that sends a jolt of excitement through the scientific community, a gas that should not be there. Methane. On our own planet, the vast majority of methane in our atmosphere is a direct byproduct of life. It comes from the digestive processes of animals like cows, from decomposing plants in wetlands, and crucially from tiny microbes living deep underground. So when our rovers and orbiters detect sudden, unpredictable spikes of methane in the Martian air, it forces us to ask an electrifying question. Is this a faint, lingering breath from a hidden biosphere of Martian microbes living beneath the frozen soil? The possibility is intoxicating. It suggests that life, even in its simplest, most resilient form, might be clinging to existence in the dark, watery aquifers far below the surface, releasing this gaseous signature as a waste product. Yet the universe rarely offers simple answers. There is a powerful alternative explanation, one that does not require biology at all. Methane can also be created by purely geological processes. A reaction called serpentinization, for instance, occurs when certain types of rock, like olivine, come into contact with water and carbon dioxide deep underground. This chemical process generates methane as a natural byproduct. So is the gas a sign of living microbes or just rocks and water interacting? The debate is fierce and remains completely unresolved. Making the mystery even deeper is the gas's bizarre behavior. The methane does not linger and build up in the atmosphere. Instead, it appears in sudden, localized puffs and then vanishes without a trace. This implies that something is actively producing it, and then something else, perhaps a yet unknown chemical process in the soil, is destroying it with astonishing speed. Each new detection is a tantalizing piece of a puzzle we cannot yet solve. A whisper on the wind that could be the murmur of a hidden world or simply the echo of a dead planet's geology. The mystery of Martian methane shows us how some of the biggest questions are hidden in the invisible. But sometimes the red planet seems to present its puzzles in the most obvious, almost theatrical way possible. A photograph from the Curiosity rover in 2022 sparked a global frenzy. It appeared to show a perfect rectangular doorway carved neatly into a cliffside, an opening that looked as if it had been made by intelligent hands. The image was compelling. It was easy to imagine a passageway leading deep into the mountain, perhaps to some long-abandoned subterranean chamber. The idea captured the public imagination instantly, suggesting an artificial structure on a world we thought was barren. Yet, just like the face in Cydonia, this door had a much more natural explanation. Geologists pointed out that what we were seeing was a simple fracture in the bedrock. On a planet without plate tectonics like Earth, the crust can still crack under stress. The immense weight of the overlying rock, combined with past seismic shaking from meteorite impacts, can cause the ground to fracture in clean, geometric lines. This doorway is likely a very small, shallow crevice, not a deep tunnel, created when a rectangular block of rock shifted and broke away from the main cliff face. The illusion is perfected by two key factors. The first is the angle of the photograph, which foreshortens the view and makes the crack seem deeper and more door-like than it really is. The second is the low resolution of the image, which smooths out the rough, natural edges and makes the fracture appear artificially precise. This is pareidolia in action once again, our brain's hardwired desire to see familiar shapes and structures in random patterns. We see a door because our minds are conditioned to recognize the signs of shelter and construction. This single image serves as a perfect case study in how to approach any strange picture from another world. The first step is to consider the scale. This doorway is only a few inches tall, not a grand entrance for giants. The second step is to look for geological parallels. We see similar, perfectly straight fractures in rock formations right here on Earth, and no one assumes they were made by aliens. The final step is to remember that Mars is a world of wind, dust, and immense geological forces, all of which sculpt the landscape in ways that can, from just the right perspective, look eerily deliberate. It is a reminder that our greatest tool for exploration is not just the camera on a rover, but a critical and questioning mind. The Martian landscape holds the ghosts of ancient deserts. Orbiting spacecraft have mapped vast fields of strange, crescent-shaped depressions and winding ridges that look like the footprints of colossal, long-vanished sand dunes. These are ghost dunes, and they are one of the most hauntingly beautiful geological records on the planet. They tell a story of a world that was not only wet but also profoundly windy. Billions of years ago, these were towering sand dunes, perhaps hundreds of feet tall, marching slowly across the Martian plains. Then, a crucial transformation began. The dunes were likely drenched by groundwater or covered in volcanic ash, and this material was rich in chemicals like chlorides or sulfates. Over eons, these minerals percolated through the sand, cementing the dune's shape from the inside out. The sand itself was then scoured away by the relentless Martian winds, but the hardened, mineralized cast remained, creating a perfect negative impression of the dune that once was. These ghostly forms are more than just fossils, they are ancient wind veins. Their distinctive U and V shapes are formed by the prevailing winds that sculpted them, and by studying their orientation, scientists can read the direction and force of the atmosphere that blew across Mars in an era long lost to time. But the most exciting possibility lies within their sheltered, hollow interiors. The protected, cemented rock of a ghost dune could have created a perfect microenvironment, shielded from the harsh surface radiation and extreme temperature swings. If ancient microbial life ever existed on Mars, these dune casts would have been ideal traps, preserving not just the shape of the sand, but perhaps even the faintest chemical fingerprints of the life that may have once called those sandy slopes home. The winds that carved those ancient dunes also helped reveal another of Mars's bizarre skin-deep secrets. High above the planet, the Mars Reconnaissance Orbiter has captured images of a landscape that looks less like a desert and more like the back of a mythical beast. Vast stretches of ground are covered in a strange, overlapping pattern of plates and scales, each one outlined with rocky ridges. It is a texture that scientists have nicknamed dragon scale terrain, and it is one of the most visually striking and puzzling geological features ever seen. This is not the work of some colossal creature, but the slow, patient sculpture of ice. The leading theory points to a process we see here on Earth known as frost heave. Imagine the ground is rich with water ice just below the surface. Over countless cycles, the temperature drops and the water in the soil freezes, expanding as it turns to ice. This expansion pushes the soil and rocks upward, creating a small mound or bump. Then, when the temperature warms again, the ice thaws and contracts, but the soil and rocks do not settle back perfectly into their original place. Repeat this cycle not for a few winters, but for millions of years. Each freeze-thaw cycle acts like a slow-motion pulse, gradually pushing the landscape into a chaotic arrangement of polygonal patches and scaly plates, all jostling against one another. The rocky material gets pushed to the edges of these scales, forming the distinctive raised ridges that we see from orbit. This dragon-scale terrain is far more than a geological curiosity. It is a giant signpost pointing directly to a critical resource. The existence of this feature tells us that vast quantities of water ice are not just trapped at the poles, but are buried in the mid-latitudes, readily available just beneath our feet. For future human explorers, this changes everything. Water is the key to survival. It is not just for drinking. It can be split into oxygen for breathing and hydrogen for rocket fuel. Finding a landscape that essentially marks the spot for subsurface ice is like discovering a buried treasure map. It means that one day, astronauts could land near these scaly plains and simply dig, knowing they will find the most precious substance in the solar system, frozen in the Martian ground, waiting to be unlocked. The dragon-scale terrain points to a world rich with frozen water, a planet that actively reshapes its own skin. Yet this same landscape has also produced illusions on a much smaller, more intimate scale. One of the most charming and widely shared examples came from the Spirit rover. As it trekked across the Columbia Hills, its camera captured an image that made the internet buzz. There, nestled among the pebbles and dust, was what appeared to be a perfectly drawn stick figure, a simple humanoid shape with a round head, 2 arms and 2 legs. It looked like a child's drawing etched into the Martian soil, a tiny piece of graffiti from an unknown artist. The immediate, thrilling thought was obvious. Could this be a sign, however primitive, of an intelligence that once walked here? The reality, once again, is a beautiful demonstration of chance and perception. This Martian stick figure was not a drawing at all. It was a random arrangement of a few small rocks, with cracks and shadows falling in just the right way to outline a human-like form. The entire figure was no more than a few centimeters tall, a miniature accident of geology and light. This is the exact same psychological phenomenon that gave us the face on Mars, playing out on a much smaller stage. Our brains are hardwired for pattern recognition, especially for the shape of our own bodies. This tendency, called pareidolia, is a survival mechanism. Spotting a potential face or figure in the bushes could have meant the difference between life and death for our ancestors. On Mars, with its alien and often monotonous landscapes, this instinct goes into overdrive. We have seen everything from a woman in a robe on a hillside to a mysterious thigh bone that turned out to be a weathered rock. Each time, our minds leap to fill the void of the unknown with something familiar. The stick figure is a perfect, humble example of this. It asks a deeper question not about Mars but about ourselves. In our eager search for neighbors, are we simply finding our own reflection in the stones? It is a reminder that the most compelling mysteries often lie in the space between what the camera actually sees and what our hopeful minds perceive. Even our smallest discoveries can spark the biggest questions. Amidst the dust and rubble of Gale Crater, the Curiosity rover's sharp eyes spotted a tiny, glistening flake. It stood out against the muted red terrain like a piece of polished obsidian or a fleck of gold. Scientists on the team nicknamed this intriguing specimen Little Colonsay, and its smooth, mirror-like surface immediately set it apart from every other rock in the vicinity. The immediate, tantalizing thought was that this could be a native gold nugget weathered out of the Martian bedrock. The idea of finding a precious metal on another world was, of course, incredibly compelling. But the team knew that appearances on Mars are famously deceptive. You cannot simply trust what your eyes tell you from 200 million miles away. To solve this puzzle, they commanded the rover to use one of its most powerful tools, the ChemCam instrument. This device does not collect a sample. Instead, it points a highly focused laser at the target, firing a series of pulses so intense that they vaporize a tiny pinprick of the rock's surface, turning it into a puff of superheated plasma. By analyzing the specific colors of light given off by that glowing vapor, scientists can determine the rock's exact chemical composition, reading its elemental fingerprint from across the solar system. This is the meticulous, step-by-step process of doing real science on another world. The analysis revealed that Little Colonsay was not gold. Its shiny appearance was likely due to it being an exceptionally smooth and dense piece of rock, polished to a high luster by the endless Martian winds. The leading theory is that this little flake is a shard of a meteorite, a piece of an iron-nickel asteroid that shattered upon impact and scattered its fragments across the crater floor. Alternatively, it could be a native Martian mineral with a particularly high concentration of reflective elements. The story of Little Colonsay is a perfect microcosm of exploration. It is a cycle of spotting something strange, formulating a hypothesis, and then using our most advanced tools to seek the definitive answer. The initial thrill of a potential gold nugget gives way to the deeper satisfaction of a mystery solved, reminding us that the true value of these finds is not in their imagined preciousness, but in the concrete data they provide about the geological diversity of our planetary neighbor. Just when we thought we had Mars all figured out, the planet presented us with a phenomenon that seemed to move. From high above, orbiting cameras began to spot dark, finger-like streaks that would slowly creep down sun-facing crater walls and canyon slopes during the warmest Martian months. As temperatures rose, these dark tendrils would extend hundreds of feet downhill, only to fade away when the cold returned. Scientists named them Recurring Slope Lineae, or RSLS, and their discovery sent a shockwave through the scientific community. Their seasonal behavior was the key clue. It looked exactly like liquid water was trickling just below the surface, darkening the soil as it seeped downhill. The implications were staggering. This was not evidence of a wet past, but a potentially wet present. If liquid water was flowing on Mars today, even intermittently, it would completely rewrite our understanding of the planet's habitability. It would mean that the most essential ingredient for life was not locked away in ice or buried deep underground, but was actively cycling in the environment, potentially creating pockets where microbial life could still exist. The search for life suddenly had a new, urgent target, but as with all things Martian, the mystery deepened with closer inspection. The problem is the Martian atmosphere. It is so thin that liquid water on the surface should instantly boil away, even at very low temperatures. How could these flows exist? One compelling theory suggested the water wasn't pure, but was an incredibly salty brine. Salt water can remain liquid at much lower temperatures and under much lower pressure than fresh water. A supersaturated brine could, in theory, ooze out of the ground and persist long enough to create the dark streaks we see. However, more recent data and experiments have pointed toward a drier, though no less fascinating, explanation. These flows might not be water at all, but avalanches of fine, dry sand and dust. The idea is that as the sun warms these steep slopes, tiny amounts of water vapor or a different volatile substance locked in the soil might be released, destabilizing the sand grains and causing them to tumble downhill in a cascade. The moving grains themselves would expose darker material underneath, creating the seasonal streaks without any liquid water being involved. This ongoing debate is critical for the future of Mars exploration. If the streaks are formed by liquid water, even a toxic brine, then they become prime locations to search for extant life. But this creates a serious dilemma known as planetary protection. We must be incredibly careful not to contaminate these sensitive areas with microbes from Earth that could hitch a ride on our rovers. A robot sent to investigate an RSL could inadvertently wipe out any native Martian life or make it impossible to tell if we found something or brought it with us. So these enigmatic dark streaks represent a crossroads. They are either the most tantalizing sign that Mars is still a living world, or they are a brilliant demonstration of how a dry, alien planet can mimic the flows of water through the movement of its own dust. For now, they remain one of the most compelling and cautious mysteries, a reminder that the most promising discoveries often require the most careful steps. The same winds that sculpt the sand can also carve the stone into breathtaking forms. Within the vastness of Gale Crater, the Curiosity rover looked up at a hillside and found a collection of spindly, towering rock spires, looking like the crumbling pillars of a long-forgotten temple. These are the Martian hoodoos, and their delicate presence tells a surprisingly robust story about the planet's history. Their formation is a lesson in patience and resistance. It begins with a layer of hard, durable rock, often a slab of tough basalt, sitting atop a much softer, more easily eroded material like sandstone. For millions, perhaps even billions of years, the relentless Martian wind, carrying fine, abrasive dust, has sandblasted the entire landscape. The soft rock wears away quickly, but the hard capstone acts like a natural umbrella, shielding the narrow column of rock directly beneath it from the worst of the erosion. Over eons, the unprotected ground around it is scoured down, leaving these protected pillars standing as lonely sentinels. We see this same exquisite process here on Earth in places like Bryce Canyon National Park, where a forest of fantastical hoodoos draws visitors from around the world. The very existence of these fragile structures on Mars is a profound clue. A hoodoo cannot form in a geologically active area. If there were frequent Mars quarks, volcanic activity, or tectonic shifts, these delicate spires would have been shaken to dust long ago. Their survival indicates that this region of Mars has been incredibly stable and quiet for an immense period of time, with wind acting as the primary and patient sculptor. They are, in effect, natural chronometers, testifying to an epoch of prolonged calm where the only thing changing the face of the planet was the whisper-thin atmosphere slowly, grain by grain, carving its signature into the rock. While we gaze at the delicate stone pillars of Gale Crater, the southern pole of Mars holds a landscape that seems spun from a nightmare. There, spread across the frozen plains, are vast, dark patterns that look exactly like gigantic spiders, some with legs stretching for half a mile. This is the areniform terrain, a name that literally means spider-shaped, and it is one of the most visually unsettling and scientifically fascinating discoveries on the planet. These are not the burrows of some colossal arachnid, but the stunning result of a seasonal cycle that is utterly alien to our world. Every Martian winter, a layer of carbon dioxide frost, what we call dry ice, settles over the polar regions, forming a transparent slab. When spring returns and sunlight penetrates this icy pane, something extraordinary happens. The solid carbon dioxide at the base of the ice layer doesn't melt into a liquid. Instead, it sublimates, turning directly from a solid into a pressurized gas. Trapped beneath the ice, this gas builds up until the pressure becomes too great, and it finally ruptures the frozen layer above. It doesn't just seep out, it explodes upward in a violent jet, carrying with it dark basaltic sand and dust from the ground below. Think of it like popping the cork on a shaken bottle of champagne, but on a geological scale. Each jet of gas and dust carves a single, narrow channel as it erupts. Over countless seasons and thousands of years, these jets erupt from the same weak points in the ice, deepening and widening the channels, creating the sprawling, radiating legs of these dark spiders. The central dark spot is the main vent where the material has been blasted out and deposited on the surface. This entire process, driven by the sublimation of carbon dioxide ice, is something we simply do not see naturally on Earth. Our planet's climate and atmospheric pressure make such a phenomenon impossible. This makes the spider terrain a uniquely Martian signature, a dramatic reminder that the forces shaping other worlds can operate by a completely different set of rules. It is a landscape carved not by water or wind alone, but by the breath of the planet itself, a frozen gas exhaling in the springtime sun and etching its ghostly, sprawling form into the ice for the entire solar system to see. That same human instinct to find the familiar in the alien gave us another viral sensation, the so-called whalebone of Mars. The Curiosity rover's photograph showed a long, smooth, and strangely curved object lying in the sand, its shape eerily reminiscent of a fossilized vertebrae or a massive rib. It was easy to let the imagination run wild, to picture the skeletal remains of some great beast that had once roamed these now silent plains. The image spread quickly, fueling speculation about a lost Martian ecosystem. The scientific explanation, however, is far less fantastical but no less fascinating. This is not a fossil. It is a rock, a piece of the Martian bedrock that has been sculpted over millions of years by the planet's unceasing winds. Think of how a river, given enough time, can carve a smooth, round stone out of a jagged piece of granite. On Mars, the atmosphere is that river. Fine, abrasive dust carried on the breeze has sandblasted this rock, wearing away its weak points and leaving behind this singular, streamlined form. It is a testament to the immense power of patient, persistent erosion. The reason scientists are so confident this is not a bone comes down to our fundamental understanding of Martian history. All the evidence gathered by every rover and orbiter points to a single, powerful conclusion. If life ever did arise on Mars, it almost certainly never progressed beyond the simplest microscopic forms. The planet's environment is thought to have turned harsh and dry far too quickly for complex, multicellular organisms to ever have the time or the stable conditions needed to evolve. Finding a fossilized bone would require a complete rewriting of that entire history, suggesting a vibrant biosphere of large animals for which we have found no other trace. This is why each new strange shape is met with a healthy balance of open-minded curiosity and rigorous skepticism. The whale bone rock serves as a perfect lesson in planetary exploration. It reminds us that our excitement for a monumental discovery must always be tempered by the steady, guiding hand of scientific plausibility. The true wonder is not in seeing a phantom whale, but in understanding the incredible natural forces that can, through sheer persistence, fool us into thinking one was ever there at all. The Martian horizon is a place of constant mystery, a line that teases us with silhouettes of the unknown. So when the Curiosity rover's cameras captured a small, perfectly geometric shape on a distant ridge, the reaction was immediate and electric. There, stark against the sky, was what appeared to be a cube. The internet dubbed it the Mars Hut, and the image of that impossibly straight-edged block sparked a firestorm of speculation. It looked like a structure, a deliberate construction placed on that barren rise. The mystery, however, was not in what it was, but in what our eyes told us it was from so far away. This was the beginning of a classic scientific detective story, one that would unfold over weeks and months. The only way to solve it was to get closer. Curiosity, our patient robotic detective, began its long, slow trek toward the ridge. With every meter it covered, the horizon shifted and the cube began to change. The first illusion broke when the rover's more powerful cameras revealed the object was not a cube at all, but a rock. The perfect right angles softened into a more conventional, though still oddly shaped boulder. The journey continued. The rover climbed the slope, its wheels crunching over the ruddy soil, until it finally reached the base of the ridge and looked up. The final reveal was both mundane and brilliant. The Mars cube was simply a small, dark boulder, no larger than a golf ball. Its seemingly geometric shape was a masterful trick of perspective, shadow, and low-resolution imagery. From that great distance, a random, jagged fracture on the rock's surface was aligned perfectly with our line of sight, creating the crisp, artificial-looking edge. The human brain, seeking order, filled in the rest, completing the square. This entire saga is a powerful lesson in the art of exploration. The universe rarely presents us with easy answers. Instead, it offers us distant, blurry puzzles. The true discovery was not a strange cube, but the process itself. It demonstrated that the only way to dispel an illusion is through patient, persistent investigation, to have the courage to drive toward the unknown, knowing that the reality you find will always be more interesting than the fantasy you left behind. Another small but exquisite discovery came from the dust-covered lens of the Curiosity rover. It looked like a tiny, branching piece of coral or a delicate flower, its petals seeming to open to the weak Martian sun. This was no fossilized plant, but a mineral formation of stunning complexity, a natural sculpture smaller than a coin. Scientists quickly identified it as a diagenetic crystal cluster. That complex term describes a beautiful process. Long ago, mineral-rich water flowed through fractures and pores in the Martian rock. As the water moved, minerals dissolved within it began to precipitate out, solidifying and growing slowly, atom by atom, into intricate crystalline structures. Think of it like the way sugar crystals form on a string in a jar of syrup, building up into complex geometric shapes over time. The particular shape of this flower suggests it is likely made of sulfates or similar salts, which are common remnants of evaporating water. The final touch was provided by the Martian wind, which acted like a master etcher. Over eons, it sandblasted away the softer surrounding rock, leaving the much harder, resistant crystal cluster in exquisite relief, as if it had been carefully placed on the surface for us to find. This tiny, flower-like object is far more than a pretty curiosity. It is a high-fidelity record of the ancient groundwater that once coursed through the planet's subsurface. The specific minerals in its structure tell a detailed story about the chemistry, temperature, and even the pH of that long-vanished water. Was it acidic or more neutral? Was it warm? How long did it persist? The answers are locked in the crystalline architecture of this tiny Martian flower, a silent bloom that holds the secrets of a world that was once, deep down, very wet indeed. The delicate mineral flowers and sculpted stones of Mars are records of a world shaped by water and wind, but some formations look less like nature and more like a blueprint. One of the most geometrically perfect examples is the so-called waffle rock, a stone slab bearing a crisp, grid-like pattern that seems stamped by a giant iron. This is not the work of some cosmic breakfast chef, but a stunning example of how simple physical processes can create breathtaking complexity. The story of this rock begins with mud and lots of it. Billions of years ago, a layer of fine sediment saturated with water was laid down in a calm lakebed or a slow-moving stream. As that environment dried out, the wet mud began to shrink and contract, fracturing into a network of interconnected polygonal cracks, much like the dried-up bed of a puddle here on Earth. This initial crack pattern is the foundation of the waffle, but the magic happened next when a new chapter began. Mineral-rich groundwater carrying dissolved silica or other hard minerals seeped down into these newly formed cracks. This watery solution filled the fractures completely, and over an immense amount of time, the minerals precipitated out of the water and hardened, forming solid, durable veins within the mud. Think of it like filling the cracks in a sidewalk with a super strong, clear resin. What you are left with is a dual-layered structure, a block of soft mudstone now threaded with a skeleton of much harder mineral. Then the final artist went to work, the relentless Martian wind. For eons, the abrasive dust sandblasted the entire surface. The softer mudstone, unprotected, wore away much faster than the hard mineral veins that filled the ancient cracks. The result is what we see today, a raised, grid-like pattern standing in relief, a perfect cast of a moment of desiccation from an unimaginably distant past. This waffle rock is more than just a curiosity. It is a fossilized snapshot of a specific climate event, a moment when the ground itself dried and split open, preserving a memory of a transition from wet to dry in the very bones of the planet. The same forces that carve spiders at the pole also paint the mid-latitudes with an otherworldly chill. When winter descends on the landing sites of our robotic explorers, the red dust turns white, not with snow as we know it, but with a blanket of carbon dioxide frost. This is a winter wonderland, but one born from the planet's thin, alien air. The frost itself is uncanny. On a cold morning on Earth, water frost paints the grass with delicate, crystalline patterns. But carbon dioxide frost on Mars is different. It clings to the ground and to rocks as a dry, icy film, more like a fine, frozen powder than a sparkling lace. Because the Martian atmosphere is so thin, this carbon dioxide doesn't melt. When the sun touches it, it simply vanishes, sublimating directly from a solid back into a gas, leaving the rusty ground bare once more. This cycle of freezing and sublimation drives the planet's entire climate. The most dramatic display is at the poles. Each winter, a massive cap of this frozen carbon dioxide, hundreds of miles across, expands from the pole, covering the landscape in a thick layer of dry ice. Then, in the spring, it retreats in a spectacular fashion, not by melting, but by turning directly into the atmosphere, causing immense winds to whip across the polar plains. By meticulously tracking the growth and shrinkage of these ice caps, scientists can measure subtle changes in the Martian climate. It is a natural barometer. A larger than expected ice cap one year might indicate a colder, stormier winter, driven by complex interactions between dust in the atmosphere and solar heat. Studying this icy pulse helps us understand the long-term climate cycles of Mars, revealing whether the planet is in a stable pattern or slowly losing what remains of its atmosphere into space. This alien frost is more than just a pretty picture. It is the frozen breath of the planet, a vital sign we can read from afar to understand the life story of a world forever caught between a watery past and a frozen present. That same distant horizon that gave us the cube illusion also produced another sudden, brilliant mystery. A photograph from the Curiosity rover showed a stark black and white landscape, and there, on a far-off ridge, was a single bright, almost blinding pinpoint of light. It looked exactly like a lamp, a beacon shining in the Martian dusk. The image went viral, with many claiming it was undeniable proof of an artificial light source, perhaps from an underground civilization venting to the surface, or even the headlamp of another unacknowledged rover. The idea was electrifying, a solitary man-made star in the alien dark. The reality, however, lies not in the geology of Mars, but in the intricate electronics of the camera itself. The most probable explanation is a cosmic ray hit. Our solar system is flooded with high-energy particles from the Sun and distant galaxies, and these subatomic bullets are constantly zipping through space. When one of these particles strikes the light-sensitive sensor of a digital camera, it deposits a burst of energy that the camera's computer reads as a bright spot of light. It is a tiny digital phantom, a transient flaw that lasts for only a single exposure. These hits are a common, everyday occurrence in space photography, something engineers plan for and expect. The other plausible explanation is more straightforward, a simple trick of the Sun. A small, exposed crystal on a rock surface, perhaps a fleck of quartz or a smooth, metallic meteorite fragment, could have been angled perfectly to catch the setting sun, reflecting its light directly back at the rover's lens with the intensity of a focused beam. This phenomenon, known as specular reflection, is like the sudden, dazzling glint off a piece of glass on a beach. The lesson of the mysterious light is a crucial one for any cosmic detective. Not every anomaly in a photograph is an anomaly on the planet. Sometimes the strange thing we are seeing is not a feature of the alien world, but a signature of the incredible and imperfect tools we use to see it. Our quest to understand Mars requires us to first understand the subtle language of our own instruments, to learn the difference between a whisper from the planet and a speck of dust on the microscope. Perhaps the most whimsical piece of Martian art was a simple utensil suspended in the sky. A photograph from the Curiosity rover revealed what looked like a single spoon, its bowl perfectly formed and its long handle stretching out, magically floating above the ground. It was an image that defied common sense, a table setting for a giant on a world with no air to breathe. The truth, as always with Mars, is a masterclass in geological patience. This is not a lost artifact, but a ventifact, a stone shaped exclusively by the wind. For millions of years, fine, abrasive sand has been carried on the Martian breeze, sandblasting every exposed surface. The spoon began as a single, resistant outcrop of rock. The wind scoured away the softer material around it, slowly and meticulously carving out the distinctive bowl shape. The handle is the key to the illusion, a thin, durable fin of rock that has managed to resist the erosion that consumed everything around it. It remains attached to a larger rock formation at one end, an anchor point hidden from the camera's view. The final touch of magic comes from the Martian light itself. A shadow is cast directly beneath the handle, so dark and perfectly aligned that it blends with the actual ground, severing the visual connection and creating the breathtaking impression that the spoon is hovering in midair. This floating spoon is more than just a fun curiosity. It is a snapshot of a process that is still ongoing. The very winds that carved this delicate sculpture will, given enough time, eventually wear the handle down to dust. We are simply fortunate enough to have seen it in this fleeting moment of its immense lifespan, a reminder that even on a dead world, the forces of nature are still patiently at work, creating transient beauty from stone and shadow. Amidst the endless rust-colored plains, the InSight lander's camera spotted something that seemed plucked from an ocean floor. It was a dark, ovoid object, smooth and elongated, with a single, delicate tendril curling away from one end. The shape was unmistakably familiar to many on Earth, a near-perfect replica of a shark egg case, often called a mermaid's purse. This bizarre little form looked utterly out of place, a piece of marine biology resting on the driest world we know. But this was no fossilized egg. The most likely explanation grounds this strange find firmly in geology. This object is almost certainly a small, iron-rich meteorite, its surface fused into that smooth, dark shell by its fiery plunge through the atmosphere. Alternatively, it could be a piece of volcanic rock, a droplet of once molten material that cooled into this peculiar shape. The strange tendril is likely just a fortunate or unfortunate bit of softer rock that eroded away, leaving this one dramatic appendage. What makes this and so many other small oddities so compelling is the unique nature of the Martian surface. Mars is a museum with perfect preservation conditions. There are no rains to wash objects away, no plant roots to overturn them, and very little geological activity to bury them. A small, distinct object like this mermaid's purse can land on the sand and simply remain there, completely undisturbed for millions of years. It sits in a state of suspended animation, waiting for a chance encounter with a robotic geologist's lens. This allows every pebble and fragment to tell its own story, turning the entire planet into a gallery of small, mysterious artifacts, each one a puzzle box from a different chapter in the solar system's long history. The Martian surface seems to specialize in these eerie echoes of life. Another rock formation captured by a rover's lens ignited a similar firestorm of speculation, this time appearing as a giant, fossilized skull staring out from the dust. The image was compelling, with deep, shadowed pits that looked like vacant eye sockets and a prominent ridge that perfectly suggested a nasal cavity. It was easy to see the silhouette of a colossal, long-dead creature, a relic from a Martian age of monsters. Our minds effortlessly connected the dots, constructing a familiar, if terrifying, face from the random shapes. The geological reality, however, is far less dramatic but just as fascinating. This skull is nothing more than a heavily weathered boulder, sculpted by billions of years of wind erosion. Those perfect eye sockets are simply random pits carved by the relentless sandblasting action of the Martian atmosphere. The nasal cavity is a fortunate ridge, a harder vein of rock that resisted erosion while the softer material around it wore away. Their alignment into a pattern we recognize as a skull is a complete and utter coincidence, a trick of perspective, lighting, and our own overactive pattern recognition. This powerful instinct, pareidolia, is the same force that makes us see animals in the clouds or a face in the front of a car. It is a testament to our brain's incredible efficiency, not to the planet's hidden biology. While the idea of a Martian dinosaur is thrilling, all the evidence we have gathered points in the opposite direction. The environment of Mars is thought to have become harsh and dry long before complex, multicellular life could have ever evolved on Earth. Finding such a fossil would require us to rewrite everything we understand about planetary evolution and the history of life itself. So these phantom skulls and bones serve as a fun, engaging reminder of our own humanity, of our deep-seated desire to find companions in the cosmos. They challenge us to enjoy the mystery, but to always trust the methodical, patient work of science to reveal the truth behind the illusion. Among the vast, empty plains of Gusev crater, a single rock stood like a lonely priest. The Spirit Rovers team unofficially named it the Bishop for its tall, slender profile and the way it seemed to preside over the flat, desolate landscape. This wasn't just a random stone, it was a landmark, a solitary spire that helped guide the rover's path across the featureless terrain. For the human operators millions of miles away, it became a point of reference, a constant in an alien world, a lonely watchtower in an ocean of dust. The Bishop's peculiar shape and isolation tell a classic geological story of endurance. It began not as a single rock, but as part of a much larger, harder layer of ancient bedrock. For billions of years, the softer materials surrounding this durable stone were relentlessly scoured away by the Martian winds. Imagine a block of ice slowly melting away, leaving only the single stubborn pebble frozen inside it. The Bishop was that pebble. The entire plain around it was systematically sandblasted down to a smooth, low level, while this one resistant formation held its ground, left standing as a solitary monument to the rock that once was. This process, the creation of what geologists call an Inselberg or isolated mountain, is a powerful testament to the immense patience of natural forces. It reveals that the flat, monotonous plains we see today are not the whole story. They are merely what remains after eons of erosion have stripped away the softer chapters of Mars's geological history. The Bishop is a surviving paragraph from that lost text, a sentinel left behind to hint at a much more rugged and complex past now buried by time and dust. While the Martian winds carve stone with patient hands, they also dance in sudden, swirling columns of dust. These are the dust devils of Mars, towering vortices that snake across the plains like ethereal ghosts. They are a constant and dynamic presence, a sign that the planet is far from a static desert. The process that creates them is a simple thermal engine. The weak Martian sun heats the rusty ground, and that warm air begins to rise in a column. Because the atmosphere is so incredibly thin, this rising air is unimpeded, shooting upward with startling speed. Cooler air then rushes in from the sides to replace it, and the planet's rotation gives this inflow a spin, coiling the air into a tight, self-sustaining vortex. The result is a dust devil that can grow to be many times taller than any found on Earth, some reaching heights of several miles, visible from orbit as they march across the landscape. These are not just spectacles, they are active participants in the Martian environment. They lift immense quantities of fine, reddish dust high into the atmosphere, contributing to the planet's global dust storms and its perpetual hazy sky. But for our robotic explorers, these whirlwinds have played a surprisingly benevolent role. The rovers, like Opportunity and Spirit, were powered by solar panels that constantly became coated in the fine, pervasive dust, threatening to starve them of energy. A passing dust devil, however, acts as a natural vacuum cleaner. Its low-pressure core and swirling winds can suck the dust right off the panels, leaving them gleaming and restored. There are documented instances where a single, fortunate encounter with a dust devil suddenly and dramatically increased a rover's power output, essentially giving it a new lease on life. These chance cleanings inadvertently extended scientific missions by months or even years, turning a force of nature into an unexpected ally in our exploration of the Red Planet. These dust devils clean the surface, but they also help reveal what lies just beneath it. Orbiting spacecraft have mapped vast regions of Mars that look like a cosmic termite has been at work, a landscape pockmarked with countless circular depressions and collapsed pits. This is the pitted terrain, and its strange appearance points directly to a hidden world below. These are not impact craters. They form when the ground above simply gives way, collapsing into a void beneath the surface. The most compelling explanation for these sinkholes is the existence of ancient lava tubes. Imagine a river of molten rock flowing across the Martian surface. The outer layer of the lava river cools and solidifies, forming a solid, rocky roof, while the lava inside continues to flow, eventually draining away completely. What remains is a long, hollow tunnel, a natural subway tube carved by fire. Over millions of years, sections of that tunnel's ceiling, weakened by meteorite impacts or its own immense weight, collapse inward, creating the pitted and chaotic terrain we see from above. These are not just geological curiosities, they are potential game changers for human exploration. The surface of Mars is a deadly place, bombarded by solar and cosmic radiation due to its thin atmosphere and lack of a global magnetic field. Any long-term human presence would require heavy shielding to survive. A lava tube provides a perfect pre-built solution. Its rocky roof, which could be dozens of feet thick, would offer complete protection from radiation and the constant threat of micrometeorites. The temperature inside would be stable, shielded from the extreme swings between day and night on the surface. It would be a ready-made outpost, a natural cavern where astronauts could live and work in relative safety. Some of the most exciting orbital images do not just show collapsed pits, but what appear to be intact skylights, small, near-perfect circular holes that seem to open into a profound darkness below. These are the potential front doors to this subterranean realm, beckoning us to venture into the unknown. The dream of a Martian base may not be a cluster of surface domes, but a settlement tucked safely within the ancient, protective bones of the planet itself, a hidden city in a tunnel forged by volcanoes. That same relentless drive to uncover the secrets beneath our feet has just led to one of the most significant geological discoveries of the entire mission. After a long and treacherous climb, NASA Curiosity rover arrived at a region the team named Bright Angel, and the landscape transformed. Before it lay an expanse of pale, heavily fractured rock, a stark contrast to the dark, ruddy stones that dominate the rest of Gale Crater. This wasn't just a different color, it was a different chapter of Martian history suddenly exposed. Initial analysis delivered a shock that resonated back to Earth. This light-toned rock was not just pale, it was absolutely loaded with pure sulfur. And not just a little bit, but so much sulfur that it is literally pure sulfur, unlike any rock the rover has ever sampled before. On a planet where every other rock analyzed has been a complex mix of many minerals, finding a spot that is essentially just one element is both bizarre and revolutionary. The leading theory is that we are looking at the remnants of an ancient river or lake bed. Billions of years ago, this area was likely saturated with water that was incredibly rich in sulfate salts. As that body of water eventually evaporated, the salts were left behind, precipitating out of the solution and forming vast deposits. Over eons, these sulfate deposits were buried and turned to stone. Now, the wind has eroded the overlying layers away, exposing this pristine, ancient record for the rover to examine. The sheer purity of the sulfur suggests the water chemistry here was unique, perhaps creating an environment that could have perfectly preserved evidence of past life. Sulfur is a key element for many microbial organisms, and such a concentrated deposit could have been a veritable buffet for ancient Martian microbes if they ever existed. This makes Bright Angel more than just a strange-looking rock. It is a time capsule from a potentially habitable niche in Mars's deep past, a place where the conditions were just right for the building blocks of life to not only exist, but to be exceptionally well preserved. The discovery opens a thrilling new line of inquiry, suggesting that the most telling clues to Mars's biological potential may be hiding in these rare, pale, and sulfur-rich stones. Even the rocks on Mars seem to defy the planet's own gravity. Curiosity once rolled up to a stone so bizarrely thin and flat it appeared to be a piece of discarded paving, a delicate slab just waiting to be lifted like a magic carpet. This wasn't a solid chunk of volcanic basalt or a hardened lump of sand. It was a flake, a wafer-thin piece of the planet's history, so finely balanced it looked as if a gentle breeze might send it skittering across the dust. Scientists recognized this strange formation immediately. It is almost certainly a piece of shale, a type of sedimentary rock that forms in one very specific environment, calm, still water. Billions of years ago, this very spot was not a windswept crater floor, but the bottom of a tranquil lake. Imagine the finest silt and clay particles, so tiny they could remain suspended in the water for years, slowly drifting down through the silent depths. They settled in an unimaginably gradual rain, one microscopic layer upon another, building up on the lakebed over millennia. The immense weight of the overlying sediment and water slowly compressed these soft muds, squeezing out the water and cementing the particles together into a solid rock, but one that forever remembers its layered origin. This is the essence of shale. It possesses a fabulously thin, parallel layering called facility, a built-in weakness that allows it to be split into sheets just like the pages of a book. The magic carpet rock is one of those pages broken off and exposed. Its delicate form is a direct result of this structure, eroding and flaking away as the Martian wind sandblasts its surface. This one strange, liftable stone is therefore so much more than a curiosity. It is a tangible piece of a lost Martian lake, a fossilized ripple of mud that once lay underwater. It confirms that Gale Crater held a persistent, stable body of water, an environment where the sediments could settle in perfect, undisturbed order, creating a geological record that has survived in this fragile form for ages beyond human comprehension. The Martian surface can sometimes feel like a cosmic gallery of individual oddities, but one discovery revealed an entire collection of alien artifacts assembled in a single, breathtaking display. The Opportunity rover, trekking across the Meridiani Planum, stumbled into a scene that would make any geologist gasp. It was a vast field littered with dark, metallic rocks, a landscape of space debris stretching out in every direction. This was not a random scattering of stones, it was a confirmed meteorite-strewn field, the first ever identified on another planet. A strewn field is the unmistakable signature of a dramatic arrival. It begins with a single, large meteoroid, a chunk of iron and nickel from the asteroid belt, hurtling toward Mars. As it slams into the upper atmosphere at tens of thousands of miles per hour, the intense friction and pressure become too much for the rock to bear. It violently fragments, shattering into hundreds of smaller pieces that then rain down across a wide, elliptical patch of ground. The pattern they form tells a story, with the largest, most durable fragments traveling the farthest, creating a trail of cosmic breadcrumbs that points back to the original object's trajectory and the immense forces that tore it apart. Finding such a field on Mars is a scientific windfall. Each iron meteorite within it is a preserved relic of the early solar system, a piece of the primordial material that never coalesced into a planet. On Earth, our active geology and weather quickly rust and erode these iron rocks, obscuring their history. But on the dry, cold, and geologically quiet surface of Mars, they can sit for billions of years in a state of near-perfect preservation. By studying their composition and distribution, scientists can piece together a timeline of bombardment, learning not just about the rocks themselves, but about the chaotic environment of the inner solar system and the frequency of impacts that have shaped the red planet across eons. This field of shattered space rock is more than a collection of curiosities. It is a historical record written in metal, a testament to the violent processes that built our cosmic neighborhood and continue to leave their mark today. Curiosity's wheels crunched over a landscape of rust and dust until it encountered a stone that seemed to have been polished by some unseen hand. Resting on the sand was a small, dark, and remarkably smooth object, its shape so perfectly ovoid that the team named it Egg Rock. This was no ordinary Martian stone. Its surface was a gallery of strange, thumbprint-like dimples and shallow, meandering grooves, a texture that set it completely apart from the jagged, wind-scoured rocks around it. Those distinctive marks have a name, rigmaglypts, and they are the unmistakable signature of a violent journey. They form when a meteoroid, a piece of iron and nickel from the asteroid belt, slams into a planet's atmosphere at a staggering speed. The friction of that hypersonic travel generates immense heat, melting the rock's outer layer. As it melts, swirling currents of superheated air literally scoop out these pits and grooves, sculpting the surface like a cosmic potter shaping wet clay. Each rigmaglypt is a frozen record of that fiery descent, a moment of ablation captured in metal. The very existence of Egg Rock and so many other meteorites like it points to a profound truth about the Martian environment. Mars has only a wisp of an atmosphere, a thin veil that offers almost no protection against incoming space debris. On Earth, our thick atmospheric blanket acts as a powerful shield, burning up the vast majority of meteoroids before they can ever reach the ground. But on Mars, countless more survived the trip intact, landing on the surface to become permanent additions to the landscape. This makes the entire planet a colossal meteorite collection, a natural museum where these iron visitors from the early solar system can rest undisturbed for eons, untouched by the rain and rust that would quickly consume them on our own world. Every dark, egg-shaped rock is a quiet testament to the endless, silent rain from the cosmos that has been falling upon the red deserts for billions of years. After all those strange rocks and shifting sands, the greatest Martian mystery remains just beyond our grasp. We have catalogued meteorites, carved spires, and ancient lake beds, but the ultimate question echoes across the emptiness. Is there, or was there ever, life on Mars? This is the final and most profound enigma, the search for a biosignature, a definitive chemical or structural clue left behind by a living organism. Our rovers have come tantalizingly close. The Curiosity rover, drilling into billion-year-old mudstones, has repeatedly detected complex organic molecules. These are the carbon-based building blocks of life as we know it, things like thiophenes and aromatic hydrocarbons. Finding them was a monumental step, proving that the raw ingredients for biology were indeed present in ancient Martian lakes. Yet here lies the crucial dilemma. These organic compounds can be forged by two very different blacksmiths, biology and geology. While life produces them, so can non-living chemical reactions like those driven by heat or the impact of asteroids. So we are left with a beautiful, frustrating puzzle. We have the ingredients, but we cannot yet prove they were ever baked into the cake of life. Then there are the haunting whispers of methane, that gas which on Earth is so often the exhaust of living things. Its sporadic appearance and disappearance is a maddening riddle. Is it the faint, lingering breath of subterranean microbes, or just the rumble of a planet's geology, the serpentinization of rocks deep underground? We have two compelling stories, one biological and one geological, and the evidence fits both perfectly. This is the cutting edge of astrobiology. It is a field defined not by answers but by possibility. We have found a world rich with the prerequisites for life: water, organic chemistry, and energy sources. We have a planet that was once strikingly similar to the early Earth, a place where life did in fact take root. The stage was set, the conditions were right, but did the play ever begin? This persistent uncertainty is not a failure, but the very engine of exploration. It is why we send ever more sophisticated laboratories like the Perseverance rover to seek out the most promising rocks to cache samples for a future return to Earth. It is why we dream of drilling deep into the icy subsurface, into those protected aquifers where life could still cling to existence. The 30 strange things we have found are not 30 answers, but 30 clues in the greatest detective story ever told. Each one, from the humblest blueberry to the most complex organic molecule, draws the outline of a world that teases us with its potential. We have not yet found proof, but we have found every reason to keep looking, to keep driving our robotic explorers toward the next ridge, and the next, forever chasing the faint, hopeful shadow of a neighbor in the cosmos. So our journey across the red deserts ends not with a single answer, but with a gallery of wonders. We have wandered from colossal faces that were tricks of the light to tiny blueberries that proved a watery past. We have seen rocks that wander, meteorites that gleam, and ghostly dunes that whisper of ancient winds. We have debated the meaning of methane whispers and the promise of dark streaks on sun-baked slopes. Each discovery, whether solved by geology or still shrouded in mystery, adds a brushstroke to a new portrait of Mars. This is not a dead world, but a dynamic and complex one, a planet with a rich history of fire, water, ice, and wind. Its story is still being written, and our role in uncovering it is only just beginning. The next great chapter is already on the horizon, with missions like the Mars Sample Return preparing to bring pieces of this alien world back to Earth for the most detailed analysis ever attempted. The greatest discoveries are still ahead of us, so keep looking up at that red dot in the sky. Follow the new images as they beam back from our robotic explorers and ask your own questions. Tell us which of these 30 strange wonders captured your imagination the most. The conversation between our world and the red one is just getting started.